All right, good afternoon, everybody. We're at the final group session here. So excited about this BIM track that we've been on. And so here we're going to go through a journey of both platforms to applications to challenges and benefits. So a nice session packed in here. Three teams presenting today, so we'll get right to that. Just one note for everybody. I was just talking to Scott, and we're going to move up the closing session, closing ceremony. So as soon as we're done here around 2:30, we'll go back over to the auditorium. We'll do the closing session. We'll get out a little early for a nice Friday afternoon. You can stroll around, or you can join a protest, whatever you'd like to do. So hopefully it'll be somewhat quiet over there, no drums or megaphones, hopefully, but if not, we'll just talk loud here. So to get us started off there, first we have UGrid up and a big data platform to visualize infrastructure assets by geolocation. So we have a team of three today. So Zhang Chen is the founder of UGrid and serial founder. He had a company before that. This is actually a spin-off of the last one, and you've worked on hundreds of transportation projects over the years, and you had this vision. You saw the silos and kind of bring them together, so that's really well, I don't want to steal your thunder because you're going to be talking about that, but you're the brains behind that, and I know you started dealing with LiDAR in there, and you've kind of gotten into more LBS, some car location there, and I know you got great things coming up too in the future on that. So let's see. Then we got Todd. So Todd Fagen is with UGrid. What's that?
Yeah, with UGrid.
UGrid
Yes.
as the director of business development, and you came over around 2019 there. The innovation that really kind of drew you in, I guess, to that. So super excited to have you here, and thanks for organizing us here for this one. And then they're not just alone. We got Don with us, so actually somebody who's using the product and actually can tell a good story about this. So Don Falcon's work, you've been, what 45 years in the biz? 35 with Ramada, did a little time with the Forest Service before that, and some private sector work. And I'm impressed. One of the big projects you finished up a couple years ago was looking at the entire WMATA system and leading the LiDAR mobile mapping scanning project for all the tunnels and everything. So that was a huge project. It was almost like $500 million deal there.
Yes, absolutely. Yeah, so we're going to talk more about it.
All right, well, let's get to it. I'm done talking. Over to you guys.
Ed, thank you very much for that introduction. We appreciate it. And thank you all for being here today. I see some familiar faces and some new ones. So thank you very much for you all spending time with us today. To learn about UGrid and also the WMATA use case, which I think is a very interesting use case, and I'm excited to explain some of that to you. But go ahead, John. As Ed introduced, we've got Zhang and Don who will be giving the more details of the project. But I'm really thrilled to have Don Falcon here because he had the vision back when they were working on this radio and cellular infrastructure improvement project to see all this digital data being collected, the LiDAR data. But his thoughts were, hey, we're going to work with it on this project, but we're also going to be able to leverage that data in the future utilizing a platform similar to UGrid. And so he brought us into this. And so what you're about to see today really is not strictly CAD or BIM or GIS. Or working on a desktop. We're a software-based solution. But what we do as a company or as a software product is we fuse all that data together on a single web-based platform. We organize it geospatially, so it's easy to access, easy to fly to, easy to scale, because Don has over 100 miles of subway system that his people need to go into the system and be able to access it. But what it does, and again, Don will explain more of this, but it saves people time, money, and even safety, because now folks don't have to go into the subway system to visualize data for their task at hand. Keeps people off the tracks and things like that. So I think that's enough of me. I'll introduce Mr. Don Falcon. You can welcome him.
Thank you, Todd. I appreciate the introduction. So I'm going to tell the WMATA story, and then we're going to actually do a little demo of how the UGrid system works in using WMATA's data. And so this project that we're going to talk about really came about because of two acts of Congress. One was in 2008, it required WMATA to provide customers with access to wireless services. Prior to that, there were a couple of repeaters. You'd ride the train. If there was an emergency, you couldn't get out on a 911 call. So it was mandated by the federal government and funded as well. The second act of Congress was in 2012, which required us to vacate our T-band radio frequencies. There was just too much chatter on that frequency, so they wanted us to move to another one. And so they paid us to do that, so they funded it. So now we have two different projects going on. We have the cell phone and we have the radio communications. So we've kind of put the whole thing together as one project, because what happens is, in a lot of times, is that, you know, I get project A and I do my thing, but now I'm competing with project B and they want to access the trackway as well. Plus we're trying to maintain the railroad. So we're constantly fighting for access into the trackway. So John, can you? So basically we're putting in cable management system to hold cables. And if you look at the lower left-hand photograph, that's what we call a cable tray management system. And by the way, I'm trying to give you the short version of this whole project because I've spent hours talking to people about this. But so it's a simple operation. Just go down into the tunnel and hang that cable tray. And that cable tray was designed to hold leaky coaxial cable. That's about 1 3/8 inches in diameter. Those are the two heavy black wires. But they have to be connected, you know, in an environment that's pretty clean. So knowing where the terminations were and how to terminate that into the equipment that you see in the second photo, or the photo on the right, so that equipment had to be placed. Now, it seems like a simple project, but it gets a little bit more complicated as we go because of the magnitude of what was actually happening. We decided that we couldn't use outside contractors other than as labor. So we ended up putting all these work trains in the tunnel, built a special cantilever work platform so that the workers could be safe. Generally, they installed this cable management system above our third rail power, which you have to protect the workers from that. So they came to us and they said, well, what kind of existing condition drawings do you have? No, stay on that for a second, please. What kind of existing condition drawings do you have? We said, well, we got these scanned TIFF images, nothing with intelligence, nothing that could be used. I said, well, what is the real problem here? And he says, well, we need to know where in the tunnel we can place this safely, where in the tunnel we can route the cable. And by the way, in between those two coaxial cables, or the leaky coaxial, they were hanging also power and fiber cables for communication. So the way the whole system worked is they'd run this leaky coaxial cable through the snake tray and then hang the cable. So we had to put 500,000 linear feet of the tray system in, and that seemed pretty simple. You find a place in the tunnel, you can pick it up. But then all of a sudden, they said, well, wait a second, we want to keep it in the windows of the vehicle. So, and then it turns out we got 1 million feet of the coaxial cable to lay, and it's thick. And what are you going to do? You have to order it in reasonable lengths. You can't curl up the extra piece. You don't want to cut the ends off because they've been terminated in the factory. And so they run these cables to the equipment on the right. They're in shafts. They have 110 shafts to install this equipment. The wiring then goes up the shaft and goes to a cell phone tower. That's how you get cell phone service in the tunnel, by making that connection. All right, so we have no existing condition. When they started to explain, yeah, you can go to the next one. They started to explain their problem with the lengths of the cables and the positions, and immediately, because I was the chief surveyor for like 33 years there, I knew tunnel construction. I knew how the whole system worked. So I said, well, aren't you guys concerned about train clearances? And they go, well, yeah, but we think we don't need to worry about it. I said, well, let's do some theoretical calculations. And that little sketch on the left, you can kind of see where that cable management tray is being hung, and using just theoretical design information. One of the worst case scenarios we found was only 2 inches of clearance from the clearance envelope of the train. The clearance envelope of the train is basically something that the train wobbles within, okay? So that's kind of has some safety factors built in. But because it was only 2 inches off, we were like, oh, well, that to me is a problem. And they said, well, why do you say that, Don? And I said, well, do you think it would be a problem if a train hit a piece of cable that was 1,000 feet long and dragged it into the tunnel? And all of a sudden, boom, oh yeah, that would be a problem. Yeah, they could just see the headlines. So in computing train clearances, you have to take into consideration, look at the sketch on the bottom, you have to take into consideration you've got a long straight train going around a curve, and the ends of the train on the outside of the curve is the end access overhang. So that train clearance envelope has to grow accordingly, and it transitions from a tangent section of the tunnel through the spiral curve into a circular curve, and it's compounded by super elevation. So the train tilts a little bit. On the middle of on the middle inside of the curve is the middle ordinate axis. So basically this train clearance envelope grows as you go through the tunnels, and it shrinks. And so, let's look at the picture above for a second. The picture above is showing what a typical piece of the tunnel looks like. Now, if you were riding in the train, you wouldn't see this, but on the left-hand side of that photo, you see a handrail or safety walk that the handrail is sitting on. And see all those wires on the wall? Well, there's no room to put that cable tray management system there. On the other side, we have a fire line. That's for supplying water in the tunnel if there was a fire. And then you could see how we're transitioning from a square or box tunnel to a circular tunnel. So now the question comes is, okay, well, how do if I place the cable tray and their target, I don't know if you can see little thick blue lines on the clearance car. Those blue lines simulate the location of the windows in the vehicle. So the idea was that you're driving down the tunnel, you look over on one of the walls, you're going to see these cables there. That's how you make your connection with your phone. So we have this problem of where we're going to put the tray, how we're going to route the cable, and then where we're going to terminate it. So when I heard all that, I said, uh-oh, we're going to need some existing condition surveys. So I started looking into the industry and said, is anybody mobile mapped in a tunnel? And so we come to find out that no one in the United States, and we couldn't find anyone in Europe, had done more than 5 miles. And you know how mobile mappers work, right? With LiDAR. They start with open sky, GPS connection. They have an inertial guidance system on them. So they got to start in open sky, they got to end in open sky, and they can't go more than 20 miles an hour, and they can't stop. So some of our tunnels were only 800 feet long. Great, that's easy. We had a couple runs that were 20 miles long. 20 miles, no one has ever done that. We said, well, let's take a chance, let's control it. So we have 5 different datums in the Metro Rail system. We had to work through all that. But look at all the noise in the tunnel just in that one center photograph. So they used a Regal scanner mounted on a work vehicle. It was also mounted with a Ladybug camera to try to get 360-degree photos. And we had a huge light plant that was just on the back of the vehicle because lighting is a problem in the tunnel. you don't have the same conditions. They're mobile mapping roads all the time. But so the vendor, the contractor that we'd hired, brought Zhang Chen to the table and said, I think this gentleman can help you, and he can help you in several ways, because we did a 5-mile pilot program. And the first thing we knew there was going to be a lot of data, 1 to 2 million points a second being collected. And we knew the photographs needed to be, coincidental with the scans. So Jean came to us and said, hey, I think I can provide a solution to you for displaying your data, to visualize your data. And I said, well, we have a bigger problem. We need to share the data with like 45 different stakeholders, all the cell phone providers, our own internal communication engineers, our own consultants. And we had a huge amount of data just in the 5 miles. I said, how are we going to deal with that? So Jean comes to the table with an interface that basically is really simple to use. And I think we could probably go right into that demo right now. So what you're going to see is a simple Google Earth type interface with an orthometric photo on top. And there we go. Okay, simple interface and a simple way to navigate. What we liked about this was you didn't have a normal human being could operate this system. Our track and structures people could operate it. So basically, you see a triangle wherever there's a scan. You see the track alignment. That was all computed by WMATA Geomatics. And then you can navigate. Now, Jean, can you go to the system map for a second? You guys have probably seen this if you've ridden the subway system. This is the map. We have colors for our different lines. So it made sense to use those colors and so we put a table on the left-hand side of the screen that says, hey, you want to go to the green line, the blue line, whatever. So why don't we go to the green line? And he came up with, the little tabs on the top that show you how to get from track 1 to track 2. And then you can also search by stationing out on the right side if you knew what station you were interested in. Or if you wanted to go right to a station platform area, there's another selection right up there to go to a platform. Platforms are shown just superimposed on the surface. So we have 52 miles of dual track, all different configurations, circular, horseshoe, square, whatever. And so let's go underground. So we're just picking the green line just because it's just one of the newer sections. This is a section between, actually this is an old section of tunnel. This is a steel liner. And we don't build tunnels with steel liners anymore for a number of reasons. We're actually in the process of replacing or aligning the L-line tunnels underneath the Potomac River because of, they're just failing. So we're removing all the cables. But anyway, here's an irregular shaped surface. And what you see on the center line of track is in red is the center line of track. Stationing for convenience sake is shown every 10 feet. You'll see another triangle way off in the distance, and you can actually jump to that next scan. Now, once in there, now we're seeing a photograph, but right behind that photograph is the actual point cloud. We'll get to that in a second. You can pan left, right, up, down. What I liked about this was that the people installing the snake tray could view an area and then could say, okay, well, we have track access in this location. Can we put snake tray or this cable management system in that area? And do we have to worry about anything? Because the data acquisition, they came to me after they had started the work. So they wanted to know where they could keep going and installing the management tray system. So Jean comes to the table and says, hey, I think I can do something with your clearances. So he shows me this. Let's just pick a point, maybe on a pipe or something on the right side. He shows me this. Boink, here comes a station offset. You can see it on the left-hand side of the screen. Station offset and the coordinates of that point on the center line of track. That's at the top of low rail or the grade profile line. And I can tell that it's a certain offset horizontally and vertically from the top of low rail. And notice that you can't really see it real well there, but that's the clearance envelope just popped up. And the clearance envelope, if you look on the right-hand side, there's a little red dot opposite the point he picked. That's a point radially closest to the point he just picked. That clearance information is shown over on the left-hand side of the screen. And I can't read the dimension, but it probably is in the range of a foot or so. So they knew that they could install the cable tray management system in that area as long as it was above that pipe. So they were able to keep going while the regular design, the 2D design drawings were being created, right? So I think the other thing is, can we go to the point cloud? Or can you see it over there? So the point cloud, you could toggle between the photograph and the point cloud, and you got it? Okay. There's the scanner. So the other thing that needed, okay, so here's the point cloud. Lots of detailed information. When he's clicking on the photograph, he's really clicking on a point behind the photograph, on one of these point cloud points. So this gave a lot of people that wanted to look into the tunnel and without going down into the trackway, the option of seeing what the tunnel looked like. Okay, well that's great. So the tunnel, now when we take people underground, and if I was a consultant and I wanted to go look at a small project, I would have to get my project manager to take down the tracks, get escorts, and get me trained and then walk me out there. Then all of a sudden, if Todd's another consultant, he just happens to have another task order, he needs to get down into the trackway. So we saved the authority millions of dollars by limiting the number of people that go into the trackway. Safety is number one at Metro these days. So anyway, so back to John, right there, let's just take a look at that. That is the actual train car in solid in orange. And you can look below it, down the side of it, above it. You have a lot of flexibility with that. He can also cut a cross section and shoot it out of this package. But the sharing of the data is probably one of the biggest features. There's the cross section. He can click on any point on that cross section and he'll get his cross-sectional, the clearance envelope to pop up. Okay, but now we have data that we have to share amongst these 45 different stakeholders. And, okay, thank you. And so, I don't know if you saw, when he jumped from the surface view to the underground view, there was a view button, but there's also a download button. So we end up with 4 terabytes of data. We have to share it with all these different stakeholders. Some of them needed the data to do their own design analysis, especially where we were transitioning over the top of a train. And so we found this to be an efficient way to update the data and share it with all the people that needed to have it. So it accomplished that need. Now, for those designs that required the exact computations needed for the length of a cable, that was done in a different system. But the fact is that we were able to order these cables in specified lengths to install them in the tunnel. So I think there's one more slide, right? Do we have one more?
You want to share the story about it?
Oh yeah. So all this occurred 6, 7, 8 years ago. We started it, and so the other day, somebody calls me up and says, "Hey, I'm looking for LiDAR drawings," and I go, "Well, I don't know what that is exactly, but what are you going to do with it?" And they say, "Well, we're replacing the emergency trip stations throughout the entire system. That's a station, that's a little box with a blue light on it every 800 feet through the system. You hit the button on this thing and it kills the power. It's not for the general public to be running down the tunnel and killing the power. but they're replacing them, and they said, well, we need to know where we can, same problem, where we can route the cables and where we can install these boxes while we keep the existing system in place. So 8 years later, we're still using the data. I'd love to have mobile mapped it maybe every 3 or 4 years. We did that mobile mapping project in 11 nights, which is pretty phenomenal once you got everything coordinated. But we had to have exclusive track rights, had to be the first one out of the chute. All right, is there one more slide? I think we're out of time here. Okay, so we're sharing the data, right, with many people. Our track and structures people love this data because they can then look at it and see what the current configuration is. We had this huge geographical area to cover. We didn't do the open sky segments of the Metro Rail. And then we are updating this data with static scans as well as scans being done with an Amberg sled. I don't know if anybody knows what one of those are, but the Amberg Technologies group has a track sled that you push along that measures 2 million points a second with very serious accuracies. So we're constantly updating the data and we're sharing it. So I'm pretty sure that wraps it up. Is there anything else that I missed there? I think we're good. Okay, there's the stats on who's using it. And so probably, what do we got? Almost 200 users that still have access. It's a secure platform for sharing the data. So thank you very much.
Oh, that was great, Don. Thank you. And as a user of Metro, thank you. I like using my cell phone. Okay. So I think we have time for a question or two for the gang here. All right.
Yeah, so looking at some of this data, it's integrated with some pretty high-tech survey equipment. What's kind of the entry level if you want to use a system like UGrid on the project? Do you need to have full mobile LiDAR, or is there a place you can exist it with maybe some high-level scans with some 360 imagery? Is there like a threshold you have to cross to get to that point?
From my perspective, anything could be used. A static photograph. The backbone is the alignment. So as long as you can give a station offset or some kind of geolocation on that image, it could be a scan, it could be a PDF, it could be anything. We just happen to be mobile mapping. Now you could go down there with other scanning devices. We did have very sophisticated survey equipment, providing control, plus all the scanning equipment. But we had the justification for the use of that kind of stuff. But pretty much anything, you could put all your as-built drawings and have them linked to that track as long as you knew where they were. We haven't done that yet. We're just using it. And he's still under contract with LaMotta to provide services as needed for future endeavors.
Yes. Sure, David.
Yeah, so I guess, and I know they've explained it to me, but maybe just for the benefit of others, how does UGrid pull the data from disparate data standards, I guess I'll call it, into one place where you can look at various, based on your need, you can look at various pieces of information. That's my understanding of what's part of what's happening, right, John?
Yes.
So how does it do that? It's not IFC based, so how does it do it?
Well, as introduced, I have a consulting background. I'm a licensed land surveyor, licensed civil engineer.
You put him to the
So work on a few hundred of these projects. Then once we started thinking to develop a UGrid, the trigger was obviously the LiDAR data. And also my consulting practice started doing LiDAR back in earlier 2000, 2001, 2002. So with all of that and how to deliver all of these different data components in one place. So UGrid has a slogan, everything is somewhere, namely georeferencing it. Collect the data under a predefined, pre-agreed, if you work with multiple stakeholders and multiple discipline, to a certain coordinate system. And once the project gets very large, you got to worry about the geodetic because the Earth is round, it's not flat, and so all of that. So luckily, and all of this data, for WMATA was collected line by line and on a certain predefined coordinates. And also luckily, giving kudos to Don and his group, when he was the head of the geomatics, the center line of the track was used in exactly the same coordinates the consultant collect this LiDAR data. It's all under this one. You're looking at, the tracks are extracted from the LiDAR data. The center line was totally developed many years before that in AutoCAD and Civil 3D. And also you're looking at other pieces from other sources, but luckily, under Don's leadership, it's all under the same coordinate. So when we bring the data in there, as long as it's on the same coordinates, the data automatically, sync together.
Because of the geospatial.
Exactly.
Very accurate.
Exactly. The real car is a moving piece. We developed that. We figured out a way how to place that based on a certain location of interest to figure out the clearance.
And then I didn't hear if you said this, Don, but are you updating this with new things?
Whenever we go back into the trackway,
Yeah.
if we're using a different technology that might get us more accurate information, then we'll update that. We'll update the existing data with the more accurate
Awesome.
information as we can.
So it's like an as-built. So-
Yes.
Okay.
Yes, they're all.
Exactly.
Yeah, there are already small segments such as the L line. We had the 8 years ago scan. We had a 2 years ago scan done by Omada Geomatics, using the Amberg card. Now the consultant for design, they also done some scanning where all of that data is kind of gathered and synced. So the next challenge actually on us is to probably do some comparative analysis, from 8 years ago to 2 years ago to a few months ago. And so that will be, some of the development challenge, we're going to be facing.
So one last request, can you scan the escalators and get those?
There are actually technology on this thing to scan that.
We're trying to scan everything.
Yeah.
We're trying to get a pic, whenever there's a project and we can use scanners on it, we do. And so all the platforms that have been rehabilitated, we start with very accurate scans, and then we verify the placement of the platform edges because of ADA requirements with very accurate scanning equipment and high order control. So I don't think any other transit authority has what Metro Geomatics has in-house capability-wise.
Yeah.
It's just, but we learned how to use it, and we use it all the time.
Yeah, I see so many benefits in having that model.
Yeah.
Just so many communications and other issues. So thank you very much. Very good.
That was great to see you great in action there. Yeah, that really gave a good flavor there. Thank you, guys. All right, next up, we have another great presentation from Austin Holliman and Morgan Ballard from Tennessee DOT. They're going to be talking about culverts. And Austin leads a team developing asset data collection, asset condition management, culvert inventory, condition asset program, and also it takes care of the FHWA emergency relief program. And Morgan, in addition to administering the call center for TDOT fix phone number, and you actually developed the reporting tools for the new culvert inspection program, and in addition to doing a whole bunch of other stuff in the maintenance division there. So I'll turn it over to you guys here. Get you plugged in and ready to go.
All right, thank you so much. All right, let's see, that came up. Hold on, let's see if we can do this really quick so we can have our notes up here. I made it angry. All right, so I got a mark. Thank you, though. was one of those things down the floor to help you with all the notes and stuff, but we got it sorted out now. So, as Ed introduced, I'm Austin Holliman. I haven't been over the Culvert program all that long. It was developed by my former supervisor before he left and went to a different division in TDOT. But I'm over it now, and we're going to talk a little bit more about it. And we're going to start with some of the program goals that we had with this. Tennessee, as a state, did not have an entire inventory of all culverts less than 48 inches across the state. Which you might sit there and be like, how do you not have that? But I mean, when you have something that was built back in the 40s and 50s, those drawings don't exist anymore. All of those culverts have been closed off and moved. So we wanted to locate all of these culverts across the state, and we wanted to standardize the collection of what we call our small structures program, which is the 48 inches to the 20-foot culverts across the state. We knew where those were, but the collection process behind them was kind of scattered and random, and they weren't being done in any type of standardized way. And then the big impetus here was replacing these culverts before they failed. And we actually had a couple failures where we didn't realize we had a culvert underneath the roadway. It collapsed and we lost the entire roadway. So after that happened a couple times, TDOT was like, we're not doing this again. So we're currently working on that. And one of the things that we really want to do is create a deterioration model for these culverts based on material, based on the location that we're putting those culverts back in. And we'll talk a little bit more about that at the end. So we're going to kind of walk through the actual culvert collection process and the major steps that we have in it. So kind of sit back, relax, and let's take a stroll through culvert land. So the first thing, as I said, it's really interesting, but TDOT just didn't have a location of any of these culverts. There was a survey done, I think, back in the early 2000s, 2010 timeframe, but it hadn't been kept up to date. There was a couple pockets that had culvert information in spreadsheets, but it was really hit and miss on what you could find out there. So I know it's really hard to believe, but underneath all of this kudzu, there's a pretty major box structure underneath this roadway. And this kudzu, this kudzu is about 6 feet high. So tramping down through it was kind of claustrophobic. But you get down there and you can see back up through underneath this 2-lane highway outside of Jackson, Tennessee. You would not have known it was there unless our maintenance crews actually found it by tramping through. They could see where the ditches were going down into this, and they're like, we think there's a culvert down there. So they tramped through this, and then as a joke, they made me tramp through it when I came out to visit them. They thought they were being funny, and I wouldn't do it. I showed them. So when we're actually doing this, you can see here on this map, this is our collection application. We use 2 Esri products, Esri Field Maps and Esri Survey 123, to capture all of these locations. All of these blue dots on the map are culvert locations that we've already collected. We use these 2 products to bring in different information about our roadway network. But here's kind of, again, this is the Middle Tennessee area right around Nashville. When we've actually finished the collection, this is what it looks like on a map. We actually have the directionality of that culvert now. We have the inlet, the outlet, if there's any type of catch basins or junction boxes on it. And then we also ask our inspectors if they're from that area, if they know that this roadway floods every time it rains, or if they know that this culvert gets blocked every time it rains. We symbolize by if it has a recurring issue, yes or no. This one they didn't know because they might not have been from that area. Here's a more expanded view. This one is actually right in downtown Nashville, not far from my office. You can see the direction that the water will be flowing underneath the roadway here, plus this other one that's going just from the median wall to the outside shoulder, and a junction box right here. Now, odds are these 2 culverts are actually connected through that junction box. What we're doing is we're using mobile technology, an iPhone and a GPS device, and we're going out there and collecting these assets. In some of these cases, our geometry is a little bit off. So what we're going to do at the end of this project is we'll start taking the geometry here and bringing it closer together to what it's actually supposed to be out there. But again, at a very high level, this tells you exactly what the culvert's doing, which direction that water should be flowing, and you can lump it in with all of our curb and gutter assets and our other drainage assets that are collected by LiDAR, and get an understanding of how that water is flowing through a project area. So then we get into assessing the culverts. After we found them, we start assessing them, and this is where our survey, our field maps and our survey 123 come in. We start off in Esri field maps, and the reason we do that is field maps has the ability to pull in other data layers that already exist for the state of Tennessee. So what you're seeing here, this is I-40, pretty close to where I live, and all of these black dots, it may be hard to see on the screen, but these black dots are every 10th mile on the highway, on the interstate here. All you have to do for an inspector, when they get out here, they just select the closest 10th mile location, and they click on the little diamond, and it gives them the opportunity to launch a culvert inspection or an under drain inspection, which is another very similar program that we're starting. Once this happens, you see all of this LRS information up here, so the county route log mile information is brought in automatically, so our inspectors don't have to sit there on the side of the road and try and figure out, okay, I'm on I-40, Davidson County, at log mile or mile marker, 212. They don't have to worry about that. Our system does it for them automatically. When we get into survey, and once you click on the launch button here in field maps, it takes you right into survey 123. It loads all of that information, and you just go through the inspection. Those are 5 pages, and you just walk through it. Everything's lined up so that you just answer question after question after question. And if you have maintenance needs or something, it asks you additional follow-up questions as you go through. We sat down and we spent, a year and a half building this application between our field users, Esri, and our office to design this so that it is very much seamless when you're out there in the field. You don't have, if you're on one side of the culvert, you don't have to leave that side of the culvert until you're done with that inspection. Then you can get up, walk across the side of the road, and go to the other side and do that inspection without leaving that side of the culvert. You'll notice here that we have colors in our inspection application. Morgan, you want to hold up one of the flip books? So we have a flip book, and we'll talk about this a little bit later, but you'll see these colors here. These colors line up across all of our materials relating to the culvert program. We have a flip book for our field users to use out there. We have a manual. We have reports for after the fact. But these colors, this green color always means scour in any of our documentation. You can take photos and you can take sketches in here. So I'm going to show the next one really quick. Here's a picture that we pulled out of our system of someone sticking his arms up underneath this big piece of concrete. Very brave. But he's sticking his hand all the way up underneath this piece of concrete. And they took a photo of it, and they had detailed what was going on with the annotate tool. They said, it's really hard to read back there. It says, inspector holding 6-foot fold ruler, end of pipe not found. So underneath this, there was water flowing out of this, but they couldn't find the pipe that was actually supplying that water. And then you can also see my very juvenile sketch here that I did just for this. I just drew it really quickly, but you can see that you can take this tool and you can draw a little diagram if you need to. Most of our maintenance and construction employees aren't going to get that detailed, but our bridge inspectors are definitely going to be that detailed on certain bridge failures. So I was talking about the flip book. It also uses photos. So we don't have a lot of descriptions in it. There are descriptions, but for the most part, the photos are what we want our inspectors to use. to detail excellent, good, fair, poor, critical criteria. And again, those colors help reinforce cognitive recognition in all of our reference material. So I'm going to show you just a second, and this is a guy we were doing training out near Knoxville, Tennessee. You can see him. He's studiously studying his flip book. But this is what he would see. So you see up here this gray part where it says barrel. I'm actually pointing at the wrong screen. My apologies. This one right here. So you see up at the very top, it says barrel. Those are on the outside of the document, so you can tab through it very easily based on color. But then you see good, fair. It gives you a photo of what both of them look like in a little standard drawing. And then when you get into poor and critical, you get different colors, you get different pictures and different standard drawings. So it's a very quick, easy visual reference to make something that can be fairly complicated as simple as possible, so anyone can pick up the flip book and take it out there with them. And we also have a full-size manual that details everything about this program. It's the entire SOP. These are up here if you want to look at them after the presentation. So now we're going to talk about digesting the data, because here is the big part, and this is where we really get into what we've been talking about this entire conference. This data is huge. There's 5 feature classes, 8 related tables. That's 13 separate tables for a total of 548 individual columns per inspection. That's a lot. It makes it to the point that you can't look at the raw data in any of the systems and really understand what you're seeing. You really have to use visualizations here to take those results and put them in a format that anyone can really understand. And the first tool in our toolbox for this is our operations dashboard. This is just a straight Esri product. Hopefully you can see most of it, but it's the best part about this Esri product too is it's almost real time for us, which is not the case for some of the others. But this one, once the inspector hits submit and that inspection goes into the server, it should show up here in the dashboard within a couple minutes. You can see all of the images out of this that they have taken out there on the field, and it just gives you some brief statistics about how our collection has been going. Those photos from earlier that were showing the directionality of the culverts, that was from zooming in on this dashboard. And it's basically anytime we have a call, this is our go-to resource. So now I'm going to turn it over to Morgan, and she's going to talk a lot more about the rest of the visualizations.
Not a lot more. You guys won't be bored, I promise. Okay. Hello, guys. I'm Morgan Ballard. I'm also from TDOT. Austin, can you go ahead and just click through? Okay. I am going to talk to you about digesting the data and specifically the dashboards that we're using, because a lot of places we find we're data rich, information poor. So it's great to collect all this stuff. It's beautiful. It's fun. We love data. We're data nerds. But if the people can't digest it, we can't utilize it, there isn't a point. So the main things I want to talk to you guys about is who our audience are for these individual dashboards, and then also who our staff are who are collecting these inspections. So like Austin stated, our bridge inspectors, they're going to be incredibly detailed. They're engineers. So when they're using the Esri application, they will go in depth, they will do things. But our app is designed so simply that a lot of our operational staff who are inspectors, they're brilliant in their own ways. You would not put me on a dump truck and expect me to like pave the roads. Don't ask me to, it would be awful. But they can't do the data analytics that we can. They don't need to understand the math behind it. They don't need to understand the configurations of all of this. They just need to be able to answer the questions yes, no, and have the application keep going through that until the entire inspection is complete. So we've designed everything with the mindset of the lowest entity, which would be our operations inspectors. That doesn't mean they're not brilliant. It just means we go to where they are and we build everything up from there. So the three main focuses I'm going to talk to you guys about for the dashboards, though, is our leadership, our general staff, and then also we do customer-focused governance, which means that it does not have my notes. That's fine. Okay, but we have customer-focused governance, which means public transparency. We can release any of this information that we need to. Go ahead and go through. So this right here is our Culvert Executive Summary Report. This is not getting into the weeds. This is for executive leadership inside the state of Tennessee. If they want to look at our culverts and see just very high level, good, fair, poor, critical, what are we rating, what is our level of service, they can drill down. Austin, may I use the pointer? I don't know how to use, thank you.
It's just the button.
Okay, if you see right here, this is our regions, and then it's also broken down by district and county, and then also route. They can come in, look, let's say at I-40, I-65, State Route 10. They could look at Davidson County, which is where Nashville is. They can look at Shelby County, where Memphis is. They could get an overall score, and they can look at these characteristics and see for energy dispensation what is the score. They can also look at embankment, end wall, and all of these elements, but at a very high level, and you're not getting into the weeds. Go ahead and next. Oh, I can do this now. Never mind, guys, I'm learning. Okay, so the next thing I want to talk to you guys about is the Culverts Maintenance Needs Dashboard. The audience for this dashboard, when we designed it, is our field staff. Our office is in a very unique position. We are asset management. Austin runs the maintenance quality insurance program. He also runs our asset collection. But then we also have our maintenance management module, and we also are operations. So we handle and deal with our maintenance staff. So a lot of people at this conference have been speaking about the fact that you're the designers, you're the brilliant minds who make these dashboards, who get the analytics, but you're not the end user. We are the end user. We deal with the end user. They call me every day. They call me on Saturdays. I hear them and I hear their complaints. So Christopher Starr, who is Austin's predecessor, and myself, and then Austin came on very early on as well. We've had alpha testing, beta testing, another beta testing, which I know sounds redundant, a phase 1 and a phase 2. And with feedback, we've created the application and everything to cater to our staff, which is great because this program, this is Asset 1, this is Culverts. Austin just stated we are moving to under drains. We're going to hopefully move to guardrail and expand it to each asset within inside the state's network. So this right here, we're designing it for them so it can be used and just progress down the line. But go ahead to show never mind, why am I telling you to do this? Okay, so this right here is our dashboard. It seems kind of busy, but this is because it's statewide. Our crew staff can limit their scope. And so if they're in region 1, so think Knoxville, Dolly's World, all of that, you can limit your scope, pick your route information, and then right here, this is an exportable table that has their maintenance needs. Because our staff isn't necessarily tech savvy, there is a keyword search right here. So if my supervisor comes in and says, I need to go to State Route 65 and do replacements of culverts, he can type in keyword replace, and the maintenance need for replace of a specific element he selected, all of that will show up for that route. He exports this Excel sheet, he has his information that he needs, and then he can start his planning process. So this is just a quick way to do that. You can see here that this embankment is selected. This map right here is only showing locations of embankments for Region 1 that are in the poor and critical stages. So that's how we can do the element rating, but it's a quick view. I keep going backwards, apologies all. The next thing you're gonna notice, this is the exact same report, but it's a secondary screen. You'll see right here, this detailed location is where we were at. That was the map feature. After they do their filtering, they can select and come to this screen, and it will pull up all the photography for those inspections. So if they want an Excel sheet with a list of locations, but then they also want to see the photography like Austin was showcasing, they can, and it will come out to them in mass. So you will see something, yes. Am I going the right direction? You'll see something like this. It says barrel. This is the end wall structure. You will see the culvert system. Do I need to point? Okay. You'll see another culvert system, but it will just generate these photos for them, and it's also labeled. Do I need to point it somewhere specific? There we go. All right, I want to very, very quickly go through this because I've been talking longer than I probably should have. This right here, these are all Microsoft Office products, just for understanding. This is Power BI. This report also works with inside Power Automate, and this is a bridge alert system. So if anything is our inspectors go out, it needs a load analysis. So it's an immediate, somebody needs to go back out there. Our staff are amazing at telling their supervisors and doing that, but this also just gets sent straight to our structures office. And this right here, as you can see, we've only had 4, but this report is basically just a frontline alert. So you don't even have to look through the data. We have those instances in place, and that's what this report is for. There we go. The last thing I want to showcase really fast, this is a Microsoft product. This is a paginated report, and this is the inspection. So if it's a singular report that you're looking for, you can see the singular inspection and all the Austin said, the columns that are entered in all of the photography. It pulls it, sorts it, and puts it in this manner. You can't really see it on the screen, but it's also color-coded to match the flip book. So again, it's these cognitive triggers that make it so the field staff don't even realize what they're learning, and it's cueing their brains as it goes forward. So everything we build will have these same hex codes, which it was great that we talked about color theory, but we've built that in already because it's needed. Austin, do you want to go ahead? And then he's going to talk about our business decisions.
And I'm going to be really fast because I know we're nearly out of time. But basically, the end result of this is making business decisions. Basically, replacement material types. We have some old mines in Tennessee that makes the water very acidic. You put a concrete pipe in there, it gets eaten out in 5 years, and it's no longer there. So we're looking to build deterioration models about that. There's the federal requirements for aquatic organism passage and bank full width. And then we're also working, and I'm going to skip ahead to that, we're working with the University of Tennessee, Knoxville to develop recommendations for repair type based on labor data and cost data as to who should be doing the replacement work. This big bar up here is contractor. This one's not considered. There was something wrong with that cohort inspection, and it was rejected by the model. Here's do nothing, and here's the little bit that TDOT can currently do in-house with our current staffing pattern. So you can see this was generated by an algorithm for TDOT to help us know where we need to be spending our money easily. And the results is we have actionable data now. In 2021, we did not have any culvert data. Today, we have over 15,500 culvert inspections statewide. So a very quick amount of collection in a very short period of time. We can now have justification to executive leadership for more money for culvert repairs. We know the locations that need urgent repairs, and money is now being set aside for culvert replacements. And then safer and more efficient transportation network, and you can see some of our contractors here performing a slip lining operation. So there's our contact information. We'll be here after this is over if you want to see the actual application itself. We'd be more than happy to demo it to you. We also have all of this reference material if you want to take a look through it. But anyway, appreciate your time and hope you have a good rest of your afternoon.
Thanks, Austin, Morgan. I think we have time for a question or two. Yes.
I just want to say great presentation. I really like how you had the end user in mind. And I think that a lot of things fail because people don't think like that. So kudos to you all. I did have a question about the data that are collected. Definitely you're using them to evaluate the culverts. Are there any, are those data going into any federally required reports for culverts at all? Or I'm not.
So
Yeah.
we haven't used it yet for that for any federal reporting. There is federal reporting required on the 48 to 20-foot structures. Those have to go into the MBIS system every 5 years, I think. There's some federal requirements on those small structures. We haven't gotten to the point that we've had to do that quite yet. But when they do, they just print this report right here and they can submit that to the feds.
And they've done that already for those 4 that we saw for the bridge load analysis. I sent all of these to our structures division, and they utilized them and kind of saved them in the filing with the rest of their inspections for the bridges. So it's data that they use in reference. It's just not integrated into their software.
Thank you.
Eric.
So first off, I'm always amazed at the number of state entities that do not have an accurate inventory of their culverts. And at the same time, study after study shows that maintaining your culverts is probably the most cost-effective thing that you can do in terms of climate resilience. So that's a long way of saying, great job. You guys are really, I can't tell you how many other states literally just have no inventory of their culverts, which to me is mind-boggling. So nice job.
I really like how it went from inspector to the dashboard and really connected them. So a lot of times you see one or the other, but you guys did a really good job of the program connecting the two. That was really nice.
All her. We said and we redesigned this presentation a couple times, but that was Morgan's idea. So she's really good at this
That's great,
stuff.
Morgan. Yes.
Can you comment on, obviously this is a combination of in-house leadership and developing this, plus the off-the-shelf type of software such as Easier or Microsoft, and then I would imagine somebody help to put this together, develop the interface coding. Can you just elaborate that process a little bit?
Yes, and that was my bad. I should have actually talked about that at the beginning. This was not all developed in-house. We developed it. There was an Esri project team and our T.IT project team. So we had 2 IT teams that were both working on the Esri products. All of the training materials that you see were produced by Arcadis for the state of Tennessee, with a team from headquarters, a team from Arcadis, and a team from our field. So it was a huge collaborative process with multiple teams, but Esri and Arcadis are big contractors that helped us put all of this together.
And they're still helping us because this is phase 2. There's going to be a phase 3. Our schema just completely changed over for phase 2. So all of the reports and everything are being rebuilt with inside that new schema. So Esri and Arcadis and our IT department, which is our great GIS team, it's a lot of effort, but it's great. Our GIS people, so in general, your staff, they come out to the field with us, which I don't know how often you guys have had to go out into the field, but we feel like it's great to have them with us because then they see the problems and we can talk about it in a more real way to get it applied.
All right. Well, one more quick question.
All right, so Zhang asked, I had 2 questions. Zhang asked the first one, but as far as training your inspectors to use the platform, what kind of an effort, what, time-wise, and do they have to, they have a support mechanism for them?
Yes. So basically training our inspectors, I have a psychology degree, so just point this out, I'm not an engineer. And so designing all of this, we have them in mind. We do, to answer it very, very briefly, we do in-person training for the rollouts, and we have great testers. We have testers that are actually testing Esri quick capture right now with us, so that's like a pilot thing. We've paused it and we've restarted it a few times, but we'll have them test it. They give me feedback, we take that feedback, we go from there. But also, they're all invested in this program because they feel like they're part of it, like this is theirs too. And we will go, they call us, they have my phone number, they have Austin's phone number. They'll call us when they have questions, but we train them in person. We give them the legal, which is this manual. They will never read this unless they have to for legal reasons. This is a heifer. It's great, but it's just a lot of information. But they use this flip book, which was actually a thought process from our old boss, Christopher Starr. And then we had to design it out with Arcadis. But this is in your hand, very easy to use. Again, you can see the good, fair, poor, critical. It's a quick reference sheet for them based off of, it doesn't matter what education level you are, this stuff is confusing. But we have these references for them to use. In-person training, we have online training that we do. We have recorded trainings on Microsoft SharePoint that are posted and available for them at any time. And then Austin is actually going to Tullahoma on Wednesday. So we did a mass training for Rollout 2, and now they meet individually with the counties to train them and have personalized discussions with them. So we have a lot of inspectors. What's our count right now?
We're probably around 150 inspectors.
We have about 150 inspectors, and we talk to them and see them. But there's about 6 of us in our office, so it's just, we make it work. Hopefully that helped.
Yes,
Well,
yes.
thank you guys.
Yeah.
That was great. All right, rounding us out for the afternoon, a great wrap up here. Natallia Mendes is a master's student in construction management at LSU, and she got her civil engineering degree in Brazil, and she worked there for a couple of years managing a bunch of sites there. And you're going to talk about challenges and benefits and current practices, and really that's your research has been focused on identifying and understanding the situation of BIM and digital twins. So wrap us up in grand fashion.
So, hi guys, good afternoon. As you listen to me well, I think so. Thank you for introducing me, Ed. My name is Natallia Mendes. I am a master's student of the Department of Construction Management from Louisiana State University. I conduct this research. I will present part of my research, my master thesis, that was developed under supervision of Dr. Carolina Barbosa Rezende. She's a professor, assistant professor from the department. He our contact if you need something, send some suggestions or enter in contact. So I briefly summarize what we will talk here. I promise to not take a long time. That is the last section, and I know everybody is going to go to home. And so I will present the objectives of this research, and I will bring a brief introduction about the concepts related to this research. And I also will provide the methodology used in this study. It's a survey, it's an online survey with the professionals from the transportation sector. So I will also provide some questions to show, and the preliminary results from this survey. I will present the current stage of this research because it's not finalized yet. I only have the preliminary results and the final considerations. So the objectives of this study, as I say, it's an online survey with the professionals of the transportation sector. The main goal here is to understand what is the companies are dealing with the construction of the design and the construction in all phases, utilizing the building information technologies and digital twins, and how these technologies can improve the process of visualization and the process of improved management in these projects. So the main focus here is building information modeling and digital twins. So to briefly introduce, I will not take a long time because we already discussed this through these 2 days, but advances in technologies are changing the way of the projects are delivered, the projects are designed and developed. So the use of technologies such as building information modeling, digital twins, artificial intelligence, big data, and machine learning are changing the way, and it allows us to visualize better the information through the process. So this technology is called smart technologies, and they are bringing more connectivity, more automation, and more collaborative process through the process, and allowing the digital delivery and bring more modernization and digitalization in the construction. So that's, I'll call it construction 4.0. So about building information modeling. So we are excited to listen about that, but to briefly bring some concept here. The building information model is a definition from Federal Highway Administration, is a collaborative way to manage data. So the building information model is a methodology that can be used in all the life cycle from the project, since the planning, design, production, construction, and operation maintenance. So visualization can be applied in all these phases. So the previous study showed successfully how we can implement these technologies and improve visualization to the operation and maintenance phase. And about digital twins. So what do we know about digital twins? So digital twins, there is a lot of definitions since the building information modeling. So when you start into looking about this, we make it stay lost, because there's a lot of definition, and these definitions change according to what field you are applying. So, but the main concept that I can bring focus on the transportation industry is that digital twins is composed by 3 components: the physical part, the digital model, and the connection between them. So some technologies can be applied together through digital twins to allowing this process that is Internet of Things and data analysis and sensors and many of technologies. So the steps of this technology is divided in 5 steps. So the first step was doing a literature review to know and learn what the previous studies and applications of building information modeling and digital twins, especially in the transportation sector. I also developed a questionnaire to apply a survey, the online survey. So the first questionnaire was developed with 26 questions, it's a big long. So before applying this questionnaire, we divided in deciding to select 3 questions to test and make a pilot of these questions to see if these questions was well developed, if the professionals are allowed to share their experience with us. And so the collect of data was divided in 2 steps: the preliminary survey, preliminary data, and the final questionnaire. Based on this final questionnaire, we will infer the conclusions about how the situation about building information modeling in digital twins. So here's we select 3 questions, as I said previously. Is composed by the preliminary survey was composed by 1 multiple question and 2 open questions. So the first one, the 3 main goals that we have in this survey is identify the most benefits of using BIM and digital technologies. So it's a multiple question that can choose, and that is also an option that you can insert some other option that I not include. And the both 2 open questions is about how this technology, what is the main challenges that the professionals are dealing with these technologies, and how these technologies are changing the transportation sector. From the preliminary results, from the multiple choice questions, we can cite the most cited benefits of the participants cited is that BIM and information in digital twins can enhance visualization. And with this, they improve the process of quality control, the conflict detection, the risk management, and they improve decision making. So the most cited is quality control, the improvements in quality control through the visualization of information. For the open questions, the main challenge cited was for the participants, it's the change of paradigm. Since it's, we know that building information is more used, applying in transportation and other fields in the construction, but especially for the digital twins, it's a kind of new, so it's is still in the first step. Some of companies and some of public agents are not using yet. So they most cited that since it's a new and a slow process, there is a little of resistance to change, since they change all the traditional way to develop projects in the construction. And they also cited the complexity of changing from the 2D models to the 2 dimensions to 3D models. So sometimes we have to, the design team develop the 2D projects, and the construction team has to develop the models from the zero, and this take a long time and can create some errors that was not previous, that is not in the 2D design. About how the technology is changing the transportation sector, the most cited is how the data is collected. So the transformation is in the information and how the data is collected, how it's processed, and how it's shared. And they also cited that the easy information, since we are working with models, all the information is from this model, and you can extract these informations automatically, so you can reduce time and reduce errors, not do it by your hands, so you can reduce the human factor of error. So it's also a modernization of the process, so it's bringing to digitalization of construction. So nowadays, we are reviewing the final questionnaire. We are basing on these considerations to finish this questionnaire. This final questionnaire will also be an online survey, was developed in a website called Qualtrics. And the idea is collect information from the private and public companies, especially from Department of Transportations, and also consultant experts from this sector, especially focused on infrastructure sector projects. So the final considerations is the final conclusions will be taken from the final questionnaire, but based on this preliminary survey, the idea is understanding how BIM, the building information modeling and digital twins are implemented during these companies, and trying to disseminate the lessons learning from this. So learning how they are fronting this, what's the most common practices, what is the most errors that they are dealing with, this is the object of this research. And we are thinking, and since here in this symposium, when you show your projects, when you show your difficulties and your success, you can share this information and avoid the other companies doing the same mistake or the same process and repeat the same process. So the idea here is avoid to making the same errors and improve the process. So the easy access to detailed information can improve the decision making, because the information is fast, but you can access the information in an easy way, in a fast way. So they can improve decision making, especially when you work in a project that's changing rapidly or drastically. So some of the benefits include the visualization, they extract the information, especially from the budget, the scheduling, and from the models. So here I will present only a briefly image from this, from what is some of benefits then you can use during these 2 days. That a lot of applications here for an example, but here's when you can integrate scheduling, model and scheduling, and when you have scheduling plus cost, you can better manage all these changes and these improvements. So you can make simulations, you can make analysis before the construction. So all this can reduce costs, avoiding excessive costs, and improve the decision making. So here is some of reference that I use in this presentation, and thank you so much for your time.
Great presentation, thank you. So questions? questions?
Have you considered or start considering overall cost benefits of using BIM and digital twins in your analysis?
Yes, some of the questions that you have in our final questionnaires is related to the cost, or if they are considering the return of investment. So I don't know if it's exactly what are you asking for, but yes, we are considering, especially because digital twins, it's required more technology and more investments. So, and yes, we are considering this. And some of the participants also mentioned this, that it's not the large part then, but some of professionals think that it's not the best way. So they are cited that the high cost, the lack of professionals that know how to use this technology is one challenge. So they training these professionals is always will increase the cost of implementation. So that is a kind of the negative point of the process, but we are considering this as well. Welcome.
So Natalia, I'm sorry if I missed it, but did you talk about like the benefits in construction or just leading up to construction planning? Have you looked at how you can bring, I'm in construction, so how you can bring some of that technology to the construction? We're running into issues where folks in the field, they have trouble with tablets and high tech and things of that nature. Just curious if you looked at that part of it yet.
I'm not focused specifically in only the construction because I want to cover all the steps, all the phases of the construction. So that is, I also am planning to consider it, the designing phase, the construction, the operation maintenance. So it's open
kind
for
of a bigger picture.
The bigger picture. So
Okay.
because if I focus, I'm thinking I thought to specify the phase, but I'm not sure if I will have a big sample, big
Right.
participants of this. So since, of course, if I will only consider the building information modeling, definitely I will have enough participants.
Well,
But
there's always follow-up research, right?
Yeah.
So I would just say that's an area, that's a gap area.
yeah, so the idea is not I don't have expectation that I will bring a lot of new discoveries, but at least starting to fill this gap because there is not too much information or previous studies in digital twins applying the transportation,
Right.
especially in the other phases. The fewer studies that I read is about maintenance, operation and maintenance phase using digital twins.
Right.
So the idea is starting to fill this gap and cover as much as possible. But in the questionnaire, we can direction according to the participant will answer. The questions are linked, so it's possible to take conclusions for each phase. So that
Right.
is the plan.
Yeah, I'll be interested to see your conclusions. It sounds like you're still wrapping it up, right? From what I saw, you're still gathering data. So
Yeah.
I'll be interested to see your conclusions on that idea of it's so slow. You know, you talk about slowness of putting it out. It's a challenge, and it maybe, you know, I'll be interested to see what you're thinking as far as how we can move it a little faster.
Yeah, so I am planning to, the idea is publish the results. So when I get the final results, I will share, I will
Yeah.
publish. And
Awesome.
it's
That
good
was
to know.
great.
It's good to know that there are really people interested in see the results. So if you want, if anyone of you want to know about my research, or if you are interested in receive the final results or participate of the full questionnaire, you can send a message for me, or you can talk to me after this presentation. I will have to share what I have with you.
I think the initial questionnaire and the responses from the initial work are fascinating, so I can't wait to see the full one. That'll be great.
Yes.
And David, when you were talking about construction phase, I think it'd be also interesting to see different types of DOTs, whether it's a state DOT versus a county DOT, or public works department, how they might answer differently. Also, since you have the digital twins in there, I think interesting to go beyond transportation. Not that I want to expand your study, but see how some of the other folks in cities who are dealing with other types of infrastructure and digital twins, we often talk about the cities part, how they're have different perspectives than.
And I think that's happening is they're starting to connect at that level, smart cities as they're calling it.
Yeah.
You know, so definitely the vertical and the horizontal are starting to be modeled together.
Yes, I'm trying to restrict the one field, but it's always good to have some suggestion and open and analyze all the options. But yeah, that is initially we are focusing infrastructure in horizontal projects, but yes, we are thinking about expand this, but I'm not sure.
That'll be
Yeah.
the next
Steps from this.
When we do this again in 2 years, you have to come back with the next.
Yeah. So.
installment.
Yes. All right. Anything else? All right. Well, thank you, and thank all for that.
Thank you.
Really appreciate it. Great session. All right, and then we can head on over to the auditorium. But I know that Morgan and Austin also have some stuff on the tablets if you want to look at that as well as the book. So.
We do. You can also find us in the auditorium or after if you really love this conference and don't want to leave right after. But we have a bunch of stuff we can showcase if you're interested.
Yeah.
Yeah, just retired.
Hey, great job.
That's what I do.
What? And the thing from it's one you can see